Little isn't equivalent to nothing, and without a doubt, Canadian space expert Paul Weird has now arrived at the resolution that the likelihood of impact for the space rock Apis is higher than previously suspected. Essentially, the 350-meter-wide object will pass near Earth in April 2029, well, given that its direction remains unaltered up to that point, obviously. Yet, that is unequivocally the essence of the matter. According to Weird, even an impact with a little object could be enough to send Apis off on an appalling way. The reality that we couldn't in fact weigh up the genuine risk right now makes what is going on no less interesting. Sadly, the space rock won't return into our field of vision until 2027. Assuming you like, Apis holds two records. On one hand, the space rock came to the highest value ever on the Turin risk scale in 2004, and on the other hand, as an alleged executioner space rock, it also set off record-breaking media agitation. Found in June 2004 by Roy Exart, David Geach Thalin, and Fabrizio Bernard, the space rock immediately pulled in the unwanted attention of being on a crash course with Earth on April 13, 2029. A Friday the 13th, no less. The corresponding impact likelihood was estimated at 1 in 37 or 2.7%, and this didn't just apply to April 2029, but also to the years 2036 and 2068. Luckily, anyway, the media and cosmic situation has long since facilitated once more, and because of detailed follow-up observations, it's now even thought to be inconceivable that Apis will come into close contact with our natural home in 4 years. Well, unless something occurs in the next few long stretches of time that literally loses the space rocket's course. However, to a greater degree toward that later, in light of the fact that essentially it's sure that even in the most dire outcome imaginable, our Earth would have a fortunate departure. At the end of the day, regardless of whether Apis were to crash into Earth, the effect wouldn't release a worldwide disaster like the space rock impact that introduced the finish of the dinosaurs quite a while back. The object, with its breadth of 350 m, is essentially excessively small for that. Albeit, on the other hand, this does not imply that the outcomes of a direct hit wouldn't be lethal. According to the specialists, the impact crater alone would demolish a region of several kilometers in diameter, and the power of the impact would be enough to obliterate an area the size of Central Europe. Communicated in calculations, this amounts to nothing less than that Apis would release an energy of 900 million tons of dynamite, which is, in turn, multiple times more significant than the horrific power intrinsic in the nuclear bomb dropped on Hiroshima. However, to influence the whole Earth's surface, it would require another multiple times more energy. The specific results of a speculative space rock impact would depend principally on where the object raises a ruckus around town. If the space rock were to collide with the ocean instead of the continent, it could cover the nearby coasts under a beast torrent more than 100 meters high, what could prompt an impact. However, luckily, we can now exile such discouraging contemplations from our minds. Since, as I said, past direction observations have shown that Apis will pass extremely close to our home planet by, how the term hair's breadth in this cosmic setting means a distance of more than 30,000 kilometers. With the goal that the 2029 space rock will still pass underneath the geostationary orbit. But at the end of the day, the all-clear given by the scientists still has a little proviso. We will only get the green light on space rocks if nothing unanticipated happens between occasionally. All in all, Apis will just miss Earth on the off chance that it keeps up with its ongoing direction. What's more, rigorously speaking, this is no more the case. A couple of years ago, researchers found that the radiation pressure of the Sun moves the space rock's orbit by around 170 m yearly, and albeit this deviation isn't adequately sufficient to coordinate AUS towards Earth in 2029, it may still lead to an effect on a later entry. Most importantly, this is by no means the only risk. Paul Weir, a specialist in orbit computations at the University of Western Ontario, warns that even the best current projections can't preclude the likelihood that AUS will be hit by a smaller object during its excursion through space. But how big would the object have to be to knock a 350 m lump off base? Well, most likely, far smaller than you think. After all, in the fall of 2022, NASA stunningly showed how the orbit of a larger object can be effectively controlled by the designated effect of a substantially smaller one, as part of the DART mission. The autonomous spacecraft had gone about as a flying battering ram, crashing into the outer layer of the 165 wide space rock, Moon Dioros. In any case, while this big diversionary move was just a test run, under real circumstances such a hit could have significantly more serious results. On this, were states that even a crash with a small space rock like those that routinely hit the Earth could move enough energy to deflect AUS from its orbit. Considering this, the specialists are highly encouraged to watch out for the spacecraft, and they would most likely do so even if they may still not see it at the moment, in reality. Anyway, Apis vanished from our field of vision as early as 2021, and since it's currently moving near the Sun, it appears imperceptible even to the most powerful telescopes in history. This will not change until 2027. But what happens in the meantime, and whether AUS may change its orbit during that time, is beyond our insight. Up to that point, since our cosmic observations were thus blinded, we chose to analyze the risk of redirection over a model recreation to figure out what kind of push it would take to put AUS on a perilous course. When AUS becomes a threat, the first step was to determine how big the corresponding diverting asteroid would need to be in order to impact AUS to a dangerous degree. During its time of being undetectable to us, past studies had already shown that the asteroid's direction would need to be moved along the side by around 200 kilometers for it to enter the next keyhole. This, in turn, refers to the small zone in the vicinity of Earth in which Earth's gravitational pull would divert the asteroid in 2029, so much that it would alter its direction to head for the planet during its next flyby in 2036. In this manner, we came to the similarly sobering and amazing conclusion that even an impact with an object only 60 centimeters across would be enough to push AUS through the keyhole. Expressed in numbers, the impact would change the space rock speed by around 0.003 of a meter per second, thus clearing the way for the necessary 200 kilometers shift in its orbit. If AUS hits us as early as 2029, however, a significantly greater force would be required to be more precise. The space rock's flight speed would need to change by around 0.05 of a meter per second. Or in other words, it would need to impact with a 3.4 m tall object. But the simple impact wouldn't be sufficient. According to Weir, it would also need to happen at a very specific time and course. But how likely is such a situation? Well, on a basic level, around 140 objects of 60 centimeters in size hit the Earth yearly, and on average, only one object of 3.40 m in diameter. However, since AUS's cross-section is considerably smaller, the impact rate is reduced accordingly. And basically, the likelihood of the space rock getting into the keyhole due to a hit is only one out of many. The risk of an impact in 2029 is even lower, where puts the likelihood of AUS being hit by a 3.4 m wide space rock at only 1 out of 100 million, and considering that only 5% of such hits are associated with a conclusive motivation, the likelihood for this case is even under 1 in 2 billion. Thus, the risk of impact can certainly be described as extremely low. However, sadly, extremely low doesn't equate to zero. As things stand, we can't totally preclude an effect, and if chance truly does eventually strike, all our mathematical expectations will no longer be very useful to us. One way or another, the specialists are highly encouraged to measure Apis's orbit as precisely as possible after it returns into our field of vision in February 2027. Then, a deviation of more than a couple of tenths of a second could indicate a disruption of the orbit. But this would not necessarily imply that the space rock is on a crash course with our home planet. And what at times gets pushed away from plain sight, notwithstanding all the impact considerations, is the fact that AUS isn't just a potential risk, but also a massive source of information. On average, a rock of this size cruises by only once every few years. So specialists are faced with an interesting opportunity to study a near-Earth asteroid up close and not just from the Earth-based observation stations. In fact, specialists are now developing a small satellite that will accompany AUS during its flyby of Earth and provide us with new insights. Thus, we will be able to bring you new recordings regularly. Kindly go ahead and tap the subscribe button now. We'd love to have you join our community so you're always up to date. From here on out, we'll see you soon.